Jai Hind viewers, we welcome you back to another expert opinion from MRO Digest Forums. MRO Digest Forums has a number of very prominent, eminent members. Today we have the privilege to be talking to one of our members, Lieutenant General Dr. Anil Kapoor. He served as Director General Electronics and Mechanical Engineers and Director General Information Systems. He's a chartered engineer. He was awarded the Eminent Engineer Award 2020 by Institution of Engineers. He is a professor of practice at IIT Tirupati and also a board member in their innovation hub. He writes and speaks on emerging technologies like C7, ISR, and AI in many publications and platforms. So, General Kapoor, the first thing which I want to ask you is that you have been talking about humanizing assets. And maybe all of our viewers are not familiar with this concept. You, I think, you have been talking about it in your various articles. Can you build the conceptual framework for this, Anil, please?
Thank you, sir. Thank you for this introduction and thank you for this forum. In fact, humanizing assets is something that I've been carrying with me, and it's an idea, the time of which has arrived. In fact, the time is overdue, and I think globally it is realized, and even India is moving towards it. It's basically using digital technology and the technology stack. But speaking about it a little conceptually to start, let me start with the strategic management mantra. Capability takes time to develop. Intention can change anytime. I mean, that is a mantra we all know, and we've grown with that mantra. And therefore, the two watchwords are capability and intention. When you look at capability into a future landscape, I feel that there are four words which are very important today. One is precision. One is positioning. Third is automation. And fourth is autonomy. So when we look at the capability matrix, I think these four are the determinants in the matrix. They are the parameters. When we look at intent, it is all technology driven. In fact, there are again four watchwords today are technology, which is a driver to this capability. Data, which once processed, and today you've got structured, unstructured, big data, and really very big data also. And therefore, that is the second huge enabler for intent. The third is semiconductor. Because when you look at technology, I think semiconductor is a great enabler, whether it is sensors, IoT, it's all driven by semiconductors. And you've got AI, you've got so many other enablers today, blockchain technology, all of them willy-nilly depend on the software so really, when we look at the whole conceptual framework, it is achieving precision in position through automation and autonomy, that is the capability. And when we look at the intent to achieve this capability, it is looking at technology, it's looking at data, it's looking at semiconductors, it is looking at software. And therefore, when we look at these 8 parameters in their totality, I call it humanized because our human body is actually about all this. And when we talk of design thinking, design anything, you design by fault analytics, which we have been doing to beat recurring faults. You design by observation. You observe nature and see what is there in nature and see, that's called design by nature. And human bodies are very much a very big proponent, the best proponent that the nature has created. And then we have the third big component is design by future needs. And if we put all this together, when we say humanizing asset, it's actually looking at your body is full of sensors. And we talk of 5' sensors, and and but internally there are many more. I mean, the inner dynamics, the inner engineering of the human body is full of nervous systems, circulation system, there's a breathing system, there is a air purification system. So it's actually a body is a system of systems and an information systems of systems. And that's why you and me, at any point in time, are able to precisely position and say, I'm having a pain here. And the body automatically responds to some stimuli, which we call conditioned reflexes. And there are some unconditioned reflexes which you. So, therefore, if we were to now model a human body with a vehicle or any asset, I think if we can bring in technology, data, semiconductor software, we'll be able to create a humanized asset. And today we are seeing it happen. I mean, all of us are seeing it happen. Alexas and all these virtual assistants actually are listening to us and responding. I mean, you say, Alexa, play a particular music, and it browses its library, whether it is Amazon library or any other library, and produces that music for you just on your call. So therefore, I think the assets are getting humanized. So really speaking, in times to come, this is going to be a big game change. And the earlier we realize and the more we focus towards it, the better our life will become. And when we look at driverless cars, unmanned systems, unmanned autonomous systems, I think they're all towards digital assets, or I'd like to call them humanizing assets. So that is the big conceptual framework.
Yeah, what you say is very fascinating. You are looking at the way technology is moving, virtually creating abilities which are like you said, humanized abilities. And that's a very fascinating way of looking at the way all of it is coming together. And similarly, in our past interactions, you have talked about software-defined vehicles. That's very interesting because we have heard of software-defined radios, but I heard from this particular term for the first time from you, software-defined vehicles. So, what is the technology stack which goes into, or into making this software-defined vehicles? Anil, please.
Right. When we look at a software-defined system, there are two prerequisites. Like I said, there is a semiconductor system and there is the software system. So it is like hardware and software. So when we look at a software-defined vehicle, what we are looking at is following technologies. First, let me talk of the big stack, and then I'll dwell a little deeper. We are looking at sensors and IoT. We are looking at geospatial technologies. And both these together actually define what we are calling precision and positioning. Then we are looking at AI platforms. We are looking at AR, VR, meta. We are looking at blockchain. We are looking at big data analytics. We are looking at quantum technologies. We are looking at nanotechnologies and nano energizers, because the size has to be very, very small. The form and fit has to be as obscure as a RFID reader. So these are the big technology stack that we are looking at. And to enable all this, what is happening today is that every vehicle is actually, every system and subsystem in the vehicle is driven by sensors and electronic control units. We've all witnessed it all our lives. And the number of sensors today is huge. I mean, there's a proximity sensor. If we were to look at a vehicle, parking as an example, the number of proximity sensors around it, in a Mercedes, the next gen Mercedes, it'll be able to park the car on its own. So then you've got the LDR sensors, you've got temperature sensors, humidity sensor, pressure sensor. There's a stack of almost 150 sensors which exist today. All this together can be actually clubbed into electronic control units. And if we look at the whole car, we look at powertrain as one system with one ECU. We may look at a suspension system with one ECU. We could look at the rear wheels as one ECU, the front wheels as one ECU. We could look at the complete electronic system or the lighting system around electrical and electronics as one system. Self-starters, alternators. So really speaking, the whole vehicle can be broken down into a number of ECUs and a number of zones. There are two technologies which actually network. One technology which networks all this is a wired technology, which is the bus system. And we have got the LIN, CAN. There are different protocols which have been established depending on the number of nodes that we establish. That is one technology. And now with 5G and other technologies coming in, Bluetooth getting very, very versatile, there are you can actually configure a LAN, a local area network, a wireless network. So you could look at a wired network and a wireless network. And all this then is put together onto an onboard computer. So the onboard computer is something that is actually going to talk to all of them. And for that, actually, what you need is a very elaborate system of software. So we talked of semiconductor. Let's talk a little bit of software. So you get a lot of data generated. Now, let me take one example to establish this point that I've communicated. Let's look at, I love this sensor called the torsion vibration sensor, because when you look at a vehicle, everything is about vibration. Most of the diagnostics is also vibration related. And vibration is about change detection, change in vibration. So let me for a moment take a vibration sensor, which is unobtrusively looking at the flywheel. Now, every teeth of the flywheel, when the flywheel rotates, actually creates a number of harmonics. For ease of mathematics, let's take the first 10 harmonics. That means every teeth gives you 10 harmonics or 10 pieces of data to study. If the flywheel has 100 teeth, in every revolution, you're getting 1,000 pieces of data. And if it moves at 1,000 RPM, just for the sake of ease mathematics, we are looking at 10 lakh or 1 million data points generating every minute. Now, that is the volume of data that is getting generated every minute. And it's each harmonic tells you the health of a different parameter in the engine. Some harmonic will talk of the initial ones about the bigger vibrations. That could be pistons, your crankshaft, your camshafts. Then it is the other systems of the engine, whether it is your piston rings, whether it is your gaskets, whether it is your bearings. So each of them is telling a story through these. And then there is a software which actually reads all this, the ECU reads all this, and then is able to tell you what and where is the next failure going to happen. In a way, it also tells you what is the status of this complete system that we're looking at. And just like a traffic light, we could actually, for ease of human interface, we could look at a digital display in a green zone, in an amber zone, and in a red zone. Anything that is in the green zone, you are safe. There is nothing to bother. Keep moving. Anything in the amber zone goes to tell you that it is not critical, but it is tending to get critical. This part is going to fail after some time, and it gives you a zone. And you know whether you're on the start of that failure or you're closing towards the red. Because when you get into the red, it is crisis zone. It can fail anytime. And therefore, when we look at a software-defined system or a software-defined vehicle, it actually comprises sensors, ECUs, doing sensor data fusion. Then there is a software which is a service-oriented architecture. We have high computing requirements because there's a lot of big data analytics, and quantum over a period of time will get into quantum computing and maybe quantum communication, because you need wired and wireless networks. Then we will need a lot of security. We'll need a lot of cyber security. So therefore, cyber kicked in, because I mean cyber and security of your complete data is very important. Now this system will engage with other systems. So you'll have vehicle to vehicle, vehicle to infrastructure, vehicle to a platform. So all these kind of interactions will be happening, and therefore you will need some of these technologies, which are radar technologies as well, and communication technology. So that EM spectrum kicks in here, and of course, a lot of information system for diagnostics, information system to health check, information system. So therefore, that is going to be the next stack, technology stack of information systems. And there'll be information that will be required by the user. There's information which is required by the service agency. There's information required by the OEM, and there's information required by research agencies. So that kind of data stack will also be available, and therefore you'll need a cloud for putting this kind of data there. And in an overall analysis, therefore, the complete vehicle is now software defined, software driven, and software controlled. And as you transcend from on the technology spectrum, you're getting from manual systems, which were largely manual, we have all done it in our lives, to partly autonomous to fully autonomous. So that is going to be the transition. So you'll have manual, partly autonomous, and over a period of time, what we call driverless cars, it will get into full autonomy. So that is the kind of transition one is looking at, and vehicle is just a platform. When I say a vehicle, it could be a gun, it could be a tank. Over a period of time, is going to be a software truck, and it will be at par. I mean, all of us who've been associated with MRO all our lives, we used to sometimes break our head on faults. I mean, you are hearing some sound, you're thinking it may be a differential, a star or a sun pinion, or is it a bearing? What is it? And you keep opening, and then you keep discovering. Over a period of time, I think this becomes easy. And let me get back to my previous one, humanizing it. It's like a doctor today. Today, he says, okay, do ultrasound, do this. He gives you a little list of tests that you're required to do your blood test. So he checks your biochemistry, he checks your physicalities. He gets into precision, he gets into positioning, and he's able to localize the problem much better with those diagnostic tools, and able to suggest to you the best diagnostics that he can offer given your condition. So I think that is where engineers are now going to transgress. So it is biomedical with equipment, if I may say. That's what the whole thought process is when we talk of software-defined vehicles.
You're so right. What you say. In fact, as you were speaking, I was trying to go back, from the type of vehicles you've seen in our lives, how it has changed and how quickly we get used to all the new sensor-driven facilities which vehicles start giving us. And then, we can't do without them. Earlier, we used to manage without them, but we can't do now. And not only that, I think it's also being driven a lot by competition, because the any vehicle nowadays, a lot of things have become the norm, that this much has to be there, even more. And what you have, this in-depth description you have given of so many aspects coming in. And you also mentioned the amount of data which is being collected, and you also mentioned that there's a possibility of diagnostics. In fact, you compared it to the diagnostics of the human body. So that brings to me the next question. Would you explain the concept of, you've been talking about this periodic preventive maintenance, and then to prospective predictive maintenance, and how and when will we see this transition, and when will it happen? What's your opinion on that, Anil, please?
That's a very good question, sir. And we've seen it all our lives. We have been into a lot of periodic and preventive, and most of our policies have been driven by that, because the end state anybody needs is reliability centric equipment. We all yearn for reliability. I mean, you want to be very, very, your mission has to be reliable, and therefore the mission has to be reliable. You look at soldier readiness, you look at equipment readiness. We've been talking about it all our lives. And let's focus a little bit on equipment readiness. And therefore, today, for want of, if I may say, adequate data, what we do is we say, okay, let's follow a periodic maintenance schedule and a preventive maintenance schedule. And based on the reliability data that we have acquired over a period of time, we define some kind of reliability parameters, some KPIs, as indices, and to achieve those indices, we define periodicities. Now, just as an example, I'll not mention the machine. There are some machines or some equipment where every 25 hours we carry out some checks. And there's another set of machine which is a little more advanced. We do it every 50 hours. And why do we do 50 days? Because there is a lot of instrumentation there which actually tells us, it speaks to us, and whenever we need to do anything in between, we do it. But 50 hours, we feel safe to do some kind of an intervention. And therefore, what we are realizing is that preventive periodic maintenance has been a mainstay for establishing the RAMD, which is the mantra of MRO: reliability, availability, maintainability, dependability. So that has been our set, and we are quite happy with it. But what we've all our lives found is the following. One, it is resource intensive. A lot of human resource, a lot of space, and a lot of just in case effort goes in. And moment you open it, even if it is, say, 30%, 40%, 50% still useful life is left. Since you opened it, you say, might as well change it now, let's not take chances. And therefore, a lot of residual life actually goes from the equipment into your discard, into the discard bin. Now, in times to come, we all talk of ROI, and we say money saved is actually money earned in a way. So I would say that any amount of reliability that we associate even with that 30% component, baby component, if we are able to capitalize on that 30%, why not? And therefore, when we have looked at a domain of a software-defined vehicle, or I'd say a software-defined equipment, which talks, a humanized asset, which talks to you and tells you exactly when you want to do, I think we can get into from periodic preventive into prescriptive and predictive. That means let's use predictive analytics. We have got a lot of big data. I just talked about the kind of big data that we are generating with all this through ECUs. And if we have a huge cloud and we have a software which only talks of change detection, only changes. I mean, anything that is ambient level green, you define your thresholds. You say, okay, this is my threshold. I'm not going to think about anything before this threshold is touched. And that threshold can be somewhere in the amber zone, either start, middle, or that's a decision the maintenance engineer has to take. And when you define that, now you get predictive. You say, okay, I'm entering the amber zone now. I think, do I have the spares, the lubes, the tools, the skill sets required to do this job? If I don't, I have a little time up my sleeve, let me organize it. And moment you touch the red, and you find that with a minimum downtime, you're able to achieve maximum. So really speaking, when we look at it from an industry perspective today, the downtime sometimes in your plant and machinery is high, primarily because you went periodic or preventive and you did not have a particular component. And once you opened it, you don't want to close it with component that is, you'd like to change. But why open it at all if it is not required? Why fix if it isn't fixed? So I'm saying that in times to come, and the time has already come, we have to shift from a just-in-case, which is periodic preventive maintenance, to a just-in-time predictive prescriptive maintenance. So it predicts and it prescribes. So that is very good for a routine way of doing things. That means fair wear and tear, when we talk of usage and aging of equipment, is very well covered by this dictum. Now let's look at a military or accident environment. I mean, in a military environment, in a TBA, an equipment which is hit, unless it is a full K kill, if it is a M kill where some maintenance is possible, some repair is possible, this is the technology which helps you. Why? Because the moment your ECUs will start talking to you. So the moment you connect up and switch on, some ECUs will say that we are fine. I mean, health is good, all is well. But some ECUs will say all is not well, and will tell you what all is not well, because the sensors, wherever you don't get data from, you know that portion is totally damaged and you would need to replace it. So really speaking, in an overall analysis, I think today time has come for us to start planning to talk about predictive and prescriptive maintenance. But we'll have to take a step back. We have a large amount of legacy equipment, whether it is industry, army, or anywhere else. Even the vehicles, all vehicles are not state of the art. All equipment is not state of the art. So, to transition, I think we will have to go in for a technology insertion or a technology upgrade. We'll have to insert some technology. We'll have to see what brings better returns on investment. And for future systems, we'll have to build in. I mean, MRO and this predictive prescriptive has to become part of your design parameter. It has to be a design requirement. It has to be a GSQR requirement for future systems. For the legacy, we'll have to see as to whether it is a cost-effective proposition. If the answer is yes, we must go in for it, and we should. And that will help us in transitioning. Till then, I think, again, four watchwords will be in maintenance will remain periodic, preventive, predictive, prescriptive, depending on what kind of technology insertion we are able to bring in and how comfortable we can be when we are transitioning from just in case to just in time. Because this is also a change management exercise, which is a human exercise. And everybody takes time to adapt to change, depending on his or her tangibles and intangible persona. So I think this is where the future lies. Over a period of time, most of us as maintenance engineers would have to look at. Today, we are looking at 80-20, 80% periodic preventive and 20% predictive prescriptive. I think the equation will change with time to maybe the other way around. I'm not saying that periodic and preventive will go out of the window, may not, because in some systems like aircrafts and others, there may be some critical systems which would still, one would want to retain that kind of a safety factor, which is very, very important. But by and large, I think the transition is inevitable. So that is what I feel about this aspect of shift from periodic preventive to predictive prescriptive reliability centric maintenance.
Thank you very much, General Kapoor. Actually, viewers, you have listened to so much information packed into a short period of time with so much of knowledge, so much of analysis, and so much. He's in the entire talk. I can see so many opportunities, both for the industry people and both for the MRO professionals. We hope to have General Kapoor back with us in future interviews where we can maybe pick up some more of these items and go into greater detail in due course of time. And with that, I would like to thank you, viewers, for being with us for this episode. The link to General Kapoor's LinkedIn profile is there in the show notes below. You're welcome to get in touch with him if you want to discuss any matter with him or engage him in any way. And we hope that you will subscribe to our channel if you like our content. We look forward to having you back with us in future as well. Our platform, MRO Digest Forums, is essentially for MRO professionals of all hues. So you're welcome to join our platform if you feel it suits you. And with that, once again, thanking Anil Kapoor for this amazing interaction. I bring this particular episode to a close. Thank you, viewers. Jai Hind.